Hello and welcome to 5.7's video on modeling with exponentials and logarithmic functions. So today's goals is we're going to use technology, aka our calculator, to find exponential and logarithmic models for sets of data. So remember, we've done this in every module before, but here are the buttons that you're going to be pressing today in the calculator. You're going to press the Stat button, which is located up at the top of your calculator. You are going to hit Edit, Enter, to get to your stats. And then you're going to type in your table into L1 and L2. And then once you do that, we are going to press Stat again, and we go to the right to Calc. And then now we are dealing with exponentials and logarithms. So our options are going to be 0 for exponential, or ln, or the natural log regression. So those are the two options that we're pressing today. So let's work through two examples together. So the first example shows the number in thousands of people that have visited Machu Picchu after the year 1990. And so we're going to type this table into our calculator, and then we're going to write an exponential model. So again, everyone press Stat, hit Enter, and then we're going to type in these numbers. And then type in your visitors into L2. I'm going to make this smaller. So not a lot of growth between those 2 years. They're both 700. Alright, so once you've got your table typed into Stat, we are going to press the Stat button again. Tab to the right to calculate, and then since number 1 says write an exponential function, you are going to go all the way down to 0, exp_reg, and click Enter. Make sure it says L1 and L2 for pulling your lists. If it doesn't, L1 is located in blue above L1, so you would hit second 1 to get L1 to come up. You don't want anything in the frequency list, and then scroll down to calculate and hit Enter, and then here is our answer. So notice it wants you to write it in the form y equals a times b to the x, and then the directions say round all values to the nearest hundredth, which would mean 2 decimals. So this would be 163.73. So you would start off with y equals what we just said, and then times. In Algebra 2 we like parentheses instead of the time symbol, and then that growth factor would be 1.08. And then we type an x at the top and we're done. So this makes sense because it's an exponential growth function and your growth factor is above 1. We also know back to exponential lessons that this is going to be growing by 8%. And then our first number is your initial value, which makes sense because that it's almost close to our original starting value. And then the good part about having a function or a model is you can predict the future. And so number 2 says estimate the number of visitors in the year 2020. So if we're starting in the year 1990, you're going to have to figure out how many years have passed between those. So if you subtract them, you would get 30 years. 30 is going to be the number of years, and so that would represent an x value. And so we're going to take 30 and substitute it in for your x value. And if you type that in the calculator, that will tell you the number of visitors in 2020. So I will give you some time to do that. I will also do it with you guys. So you would type 163.73 parentheses 1.08 to the 30. So that is roughly the amount of people in thousands that visited Machu Picchu. Now, whoops, we do need to round that number because you cannot have 0.5 of a person. So if we round that up, it will be 1,648 visitors. Now this is thousands of visitors. So what that really means is if you put comma 000, roughly 1,648,000 visitors in Machu Picchu. Boop, boop. So that is an exponential model. Let's look at a logarithmic model. Bloop. All right, so air pressure decreases as altitude increases because there are fewer air molecules at higher levels. So what that means is you can have shortness of breath. So at higher altitudes, there's less oxygen available for breathing, and so your lungs have to work harder to deliver oxygen into the bloodstream. You can also get what is called as altitude sickness, where people who spend too much time at high altitudes can experience sickness, which includes headaches, dizziness, and more serious symptoms. So fun fact, air pressure and sea level is a logarithmic function. So for example, here's Mount Everest at an altitude roughly up there, and then you've got your sea level atmospheric pressure. So the atmospheric pressure decreases with increasing altitude. So at sea level, the average air pressure is 1 atmosphere, which is roughly that many kilograms per square centimeter. And so the table shows the amount of air pressures in atmospheres and the altitudes in kilometers. And so what we're going to do with this table is type it into stat. So go ahead, press pause. I'll save you the time of watching me type this into stat. Alright, so I've typed my data into stat. And if I show enter, I've got my x values in L1 and my y values in L2. Once you have that typed in, press stat and go to the right. And number 1 says use technology to find a logarithmic model. And so the only logarithmic option would be the natural log. So go all the way down to press 9. Make sure it says L1, L2, and calculate. So there's our answer. Now again, it tells you at the top how it wants you to write it. It wants you to write y equals a plus b and then the natural log of x. And so we are going to round to, doesn't tell me. Okay, let's do 2 decimals. So you would have y equals, or in this case, h equals, because that's how they want us to write it. 0.86 would be your a value. And then your b value, instead of a plus, it would be minus 6.45 natural log of x. And so there is your logarithmic model to help you with this problem. Now again, if you have a model, you can predict another number. So it says estimate the altitude when the air pressure is 0.75 atmosphere. So I am looking at air pressure because it's in atmosphere. So 0.75 would roughly be right here. So I'm predicting the altitude is somewhere between 0 and 5. So let's see if that is true. So this 0.75 is an x value. So I'm going to substitute it in for my x value. So you type that in the calculator, and then that would tell you the altitude or height. So let's do that. 0.86 minus 6.45 natural log 0.75. So then that makes sense because that number was roughly in between 0 and 5. Gosh, like I predicted. And then round to the nearest hundredth. So 2.72. That would be our altitude. So that is using stat to find exponential and logarithmic functions. So you guys are done, and you can head to Delta Math to practice. Again, make sure to focus on the rounding on Delta Math because it's pretty nitpicky. Also, if you ever have any issues with the calculator, to reset it, you can press second plus 712, and that will fix any issues that may have come up. So if you had, for example, a column missing, that will fix it, etc. So thanks for watching. Have fun.